Continuing now in our geometry unit, I want to talk about volume this week. And before we do that, I want to review what we talked about last week with regards to area and perimeter. Here I have a square, and the area of my square can be found by taking my side lengths, 5 inches by 5 inches, and then multiplying those together. And we started doing that back in 3rd grade with area models for multiplication. We did that in 4th grade. And so 5 times 5 is 25. Inches times inches is inches squared. And so area is the number of squares that fit into a 2D object, or the amount of stuff in a 2-dimensional or a flat object. Perimeter, on the other hand, is found by measuring the distance around a polygon. And so I have 5 inches, and then of course I'd have 5 inches and another 5 inches. And so if I were to go around this particular polygon, that's 5, 10, 15, and 20. So my perimeter would be 20 inches, not inches squared, but it would be 20 inches because it is a linear measurement. And so inches plus inches plus inches plus inches is still inches. All right, and then volume is similar to area in that volume is the amount of stuff inside of an object, but this time it's the amount of stuff in a 3D object. Instead of a 2D object, it's the amount of stuff here in this 3D object. And so my textbook defines it as the number of unit cubes that can fill up a particular object with no gaps, no overlaps. And again, it's just the amount of stuff that's in my 3D object. Now we do need to talk about what a unit cube is. Now a unit cube is just a cube that's just one unit on all sides. Now depending on whatever that unit is. So I could have 1 centimeter by 1 centimeter by 1 centimeter, and there's a centimeter unit cube. I could have 1 foot by 1 foot by 1 foot. There's a foot unit cube. Or I could have, for example, 1 meter by 1 meter by 1 meter, and there's a meter unit cube. And what really the only important thing is for a unit cube, it's just one of whatever that unit is on all sides. All right, so a reminder about units, what we talked about last week. Linear is going to be just in whatever that unit is. So for this example, this line segment we say is 5 inches. And so that is just going to be a 1-dimension or 1-direction measurement. And so as we talked about before, 5 to the first power is just 5. Inches to the first power is inches. And so it's that 1 indicates that it is 1 direction or 1 dimension. It's a linear measurement. For a 2-dimensional object like this rectangular prism, then I have 2 directions or 2 dimensions. I have a length and a width, or a base and a height, depending on how you want to look at that. And I'm just going to measure in those 2 directions. So I have 2 times 5, which is 10. Inches times inches is inches squared. For a 3-dimensional object, I'm going in 3 directions or 3 dimensions: length, width, and height, or base, area, and height. And I'm just multiplying those together. So 8 times 2 is 16, times 2 is 32. And these are inches times inches times inches, which is inches cubed. Linear could be inches. I could measure it in feet, yards, centimeters, miles. For area, square inches, I could say square feet, square yards, square miles, etc. And for volume, I have inches cubed. I could have feet cubed or cubic feet. I could have cubic yards or yards cubed, cubic miles, etc. And it's just going to follow that same pattern. But what we noticed and what we talked about briefly last week is that if I have just a linear measurement or have that hidden 1 there, if I just see inches, I know that that's linear. That's going to be a 1-dimensional object. If I see that I have this squared or 2, that's going to be a 2-dimensional object. And if I have units cubed, that's going to be for a 3-dimensional object, and I'm finding volume. So there's going to be some clues there in your word problems. So I know if I see cubic units, then I have volume. I'm dealing with volume of a 3-dimensional object. If I see square units, then that is a 2-dimensional object dealing with area. And if I just see the units, then that is going to be a linear measurement. Looking back at our MVP and what we talked about last week, so for area, we have area is going to be base times height, 1/2 base times height, depending on whether what my polygon is. And so my base is what we usually call the length and the width. Now we're calling the base and the height. And so I have my base of my 2D figure and the height of my 2D figure. And then I want to relate that to volume. Now, first off here, here's my two-dimensional figure, and it does have a base and it does have a height. Now for volume, I now have base area times my height. And it's important to note, and it is silly, and I very much disagree with this and them calling it this, but here I have height, and that's the completely different thing. It's not the same thing as this height. Even though it has the same name, has the same variable, it is a completely different thing. And so if I were to take this shape here and make that be the base of this cube, then you see I have base, which is here, and I have height, which is here. That's my base and my height that I identified as part of my two-dimensional object, but that's different. This height and this height are completely different things. Here's the height of my rectangle, and here is the height of my cube. And so they are two different things, even though they have the same name and they have the same variable. Now, it's the height of my 2D object versus the height of my 3D object. And once again, just like I talked about last week, don't get hung up on what they're called. Just understand the concept. So if you understand that on a 2D object, I'm multiplying this times this, you're doing fine. On a 3D object, on a rectangular prism, I'm just multiplying my three quantities together, regardless of what they're called, then you're going to be fine. Now, the first thing you notice is that I do have this square here, and the square is a 3 by 3 square, so 3 times 3 is 9. It is a flat object. It is just two-dimensional, and so that is an area of 9 square units. But if I were to go ahead and build a layer on it, now I have a 3D shape. I have a rectangular prism. But when I look, the area did not change. The area is still 9 square units. What changed is now I have a height, but this time I have a height of 1. So I have 9 cubic units for this prism. But I can go ahead and add another layer onto it. And let me go ahead and do that, and then add an additional layer. And so now what I end up having is a rectangular prism. But when I look at it from the top view, notice that the area did not change. The area is still the same. That base area is still 9, but I have a height of 3. So now that I have a 9 by 3, this took 27 cubes to build. So I have a volume of this rectangular prism of 27 cubes. Here I have a rectangle. This is a 2 by 4 rectangle. So it's an area of 2 times 4, which is 8, but it is flat. So I just have an area of my 2D shape, but I can go ahead and build a layer on there, make it a 3D shape, a rectangular prism, but my area is still the same. My area is 8 with a height of 1, so my volume is 8, at this point 8 unit cubes. But I can go ahead and do like I did before and just add on some layers. And so I'm going to go ahead and do that. So we'll add some layers and see what happens to our volume. Also what happens to our area as well. So first things first, we look at our area. The area stays the same. So my base area is still 8. It didn't change. What changed is my height of my 3D figure, or the number of layers. It's now 4 layers tall. So 8 times 4 is 32, meaning that it took 32 cubes to build this rectangular prism. And so that's volume using Minecraft blocks. And so it's pretty simple, pretty straightforward. Hope that helped to make some sense of it. All right, so now we've looked at some examples on how to calculate volume and how volume works. Let's compare the formulas from 5th grade and 6th grade. So here I have this prism. They're going to fill it up with centimeter cubes, and there's no gaps, no overlaps. It says here on the left side, what are the length and the width of the base of the prism? So the length is 4 centimeters. My width, 3 centimeters. And it says how many layers of unit cubes are needed. Well, these are centimeter cubes. I need to go 6 centimeters high, so I'll need 6 layers. Looking over at the right side, it talks about the base area, right? So base area, that is capital B. And so my base area is going to be, well, how many cubes does it take to make that base layer, that bottom layer? So I look here, I count them up, it's 12 cubes. So my base area is 12 centimeters squared. And then how many layers tall? Well, it's the same thing, 6 layers tall. 5th grade formula, volume equals length times width times height. 6th grade formula, volume equals base area times height. Let's go ahead and apply our numbers. So my length times my width, 4 times 3 times my height. 4 times 3 is 12, and then 12 times 6. And on my 6th grade side, my base area was 12, and then times my height of 6. And so then I multiply those together to get my volume in cubic centimeters. What do you notice about the two formulas? What similarities do you see? Well, we got the same answer, and really and truly, they are the same thing because this is the same as this. It's just finding my base area. But basically, they are the same thing. So moving on, 2 more examples. The rectangular prism is to be filled with centimeter cubes without gaps or overlaps. Determine the length, the width, and the area of the prism's base. So look at my length. I have 5 centimeters. My width is 5 centimeters. And my area is going to be, I'm going to multiply those two together. So 5 times 5 is 25. Centimeters times centimeters is centimeters squared. How many layers are needed to fill the prism? Well, it says that it is 5 centimeters high. So that is going to be 5 layers tall. So the prism is a cube. Which variable represents the number of layers of unit cubes? And so I have volume equals side times side times side. Now this is really the same as volume equals base area times height. My base area is really just side times side, and then I'm multiplying that by the side length. So this works for all cubes, does not work for anything else. So this is a special formula for cubes, but you don't even have to memorize this because it is exactly the same as that. Use the formula volume equals side times side times side to determine the volume of the prism. So it's just 5 times 5 times 5. And of course I have centimeters for my units. 5 times 5 is 25. 25 times 5 is 125. And that is centimeters cubed. On the other side, the rectangular prism is to be filled with centimeter cubes without gaps or overlaps. Here they did not give me the little pictures of the cubes. I just have lengths. So hopefully that's still going to be okay. Let's find out. Volume equals length. Well, we'll call that 10 centimeters. Width, let's call that 5 centimeters. And a height of 7 centimeters or 7 layers tall. And then I just need to multiply these. Now, because multiplication is commutative and associative, I can do this in any order. So 5 times 7 is 35. 35 times 10 gives me 350. And that is centimeters times centimeters times centimeters, which gives me centimeters cubed or cubic centimeters. Formula volume equals base area times height. What connections can be made or may be made between volume equals base area times height and volume equals length times width times height? Well, they're the exact same thing. And what connections can be made between volume equals base area times height and volume equals side times side times side? Well, this only works for a cube. And so what we know is that this formula will always work no matter what. And so this is what you'll see for the next several years anyway. Whether in next grade, in 7th grade, you'll be doing triangular prisms. And so you'll find the area of the triangle. Then you'll multiply that by the number of layers or the distance between the bases. It can be used for trapezoidal prisms, hexagonal prisms, and so on. So any kind of prism can be found by using this formula. So hopefully this all made sense. If you need help, definitely meet me in the Google Meets session. Send me an email. Other than that, have fun with this week's lessons.